Good day, everyone. So, today we shall be looking at technological applications of physics. All right, a lot of students just think that this subject is abstract, but no, it has its own application. So, today we are looking at the technological application of it, and we shall be focusing on the uses of machines. All right, without further ado, let's dive into this. All right, you know, why does physics really matter? Does it really matter? Does it really have any impact in our world? This subject is not an abstract subject, like I mentioned earlier. It's about solving real problems. In fact, engineers use the principles of this subject to invent, to design, and maintain everyday tools and machineries. We use these inventions in agriculture, in transportation, and even in industries. They rely on this subject called physics. Okay, so it is never an abstract subject. It is a real life solving subject. Okay, real life situation solving subject. So it is not abstract at all. And then we are looking at machine today, the uses. First of all, let's talk about what a machine is. A machine actually is any device that make our work easier by changing the size or direction of a force. Okay, so you make our work easier by changing the size or direction of a force that we apply to it. Machines do not really reduce the amount of work we do, they just make our tasks easier or more manageable. Okay, it just make the tasks that we have to be more easier for us. It doesn't reduce the amount of work we want to do. And we have two categories of this machine. We have the simple machine and we have the complex or sometimes called compound machine. And we can find this machine in anywhere, in our homes, in our farm, in our vehicles, in factories. These machines are just everywhere. Okay, so now let's talk about the simple machine. The simple machine is just classified into 6. Okay, we have the lever, the inclined plane, the wheel and axle, we have the pulley, we have the screw, and we have the wedge. Okay, now the complex machine that we have today are just simply the combination of those simple machines. When we combine 2 or more of this simple machine, then we have complex machine that we use today. All right, now let's talk about one of the classes of this simple machine, the lever. The lever is simply a rigid bar that rotates around the fixed point called the fulcrum. You see it here. So it's a rigid bar and it rotates around a fulcrum, a point called fulcrum. There's a fulcrum here. So example of this is the seesaw that we use. We use in primary school that children use. That one that goes up and down. Okay, that's an example of a lever. So the point where it is rotating is called the fulcrum. So there is load at one end and at the other side force is applied, or what we call effort. Okay, so that makes it a machine. So we have example of it, and I mentioned earlier, the seesaw and also the wheelbarrow. The wheelbarrow is another example of lever. But this lever is classified into 3 classes. We have the first class, we have the second class, and we have the third class. The first class lever are the one that have the fulcrum between the effort and the load, as you've seen here. When the fulcrum is between the load and the effort, that type of lever is now a first class lever. An example is the seesaw, the one we could see in the primary school where children play with. One sit at one end and another person sits at the other end, and it goes up and down. So the fulcrum is at the center, the turning point. Now the second lever, in this case, we have the load between the effort and the fulcrum. Okay, if you see a wheelbarrow, you see that the load is always at the center. Okay, while the effort is the handle side, and then the fulcrum is at the tire side. Okay. Now the third class lever is the one where we have the effort between the load and the fulcrum. Okay. So in this, we can see that in the fishing rod, the rod we use in catching fish, the sea. You have the effort being applied between the load and the fulcrum. All right. So that's lever forward. One of the classes of simple machine. Let's talk about another class, that is inclined plane. An inclined plane is just a flat surface set at an angle to another surface. You can see it here. This is an inclined plane. Okay, a flat surface that is just raised at an angle. And what does it do? What does it do rather? It helps to reduce the force that we need to lift the load. Imagine you want to take a load from down to up. You can imagine the number of staircases you have to climb. But if you place an inclined plane between the upstairs and the downstairs, all you need to do is just to push the load within that inclined plane and it gets up. So it helps to reduce the force that we need to lift objects by increasing the distance over what the force acts. And where you can see that example is the truck. The truck that usually offload. You can see the way the inclined plane in the truck moves, and also the wheelbarrow we use in the market too. Wheelbarrow is a kind of inclined plane because it can also be inclined at an angle, and you could easily pull your goods out from it. So let's talk about another simple machine that is called the wheel and axle. The wheel and axle consists of a large wheel. You can see the wheel here attached to the axle, and then the turning of this wheel make it easier to move the load. And you can see that this is the area it can be applied in a grinding mill. Okay, a grinding mill. So as you are turning the wheel, the axle moves and allow the grinder to be able to grind the content. So it is very, very applicable. We can also find the wheel and axle in our bicycle. In our bicycle, as you are pressing the pedal, the wheel begin to turn, and it makes the tire to be able to move forward or backward based on the direction of the force applied. So it's another simple machine that we have. Okay, another simple machine we have is called the pulley. The pulley is just a combination of a wheel and a groove. As you can see here, there's it here. There's a groove, and there's a groove where it is suspended, and then the wheel. So as the direction of the force is changing, it helps in lifting the loads. It is applicable in well. You can see it's attached in well most of the time. When you want to draw water from the well, you make use of pulley. So as you're applying your force on the rope through the groove and the wheel, the object begins to come up. Okay, so it makes the force we apply to lift our object with ease, just applying little force. So we can use it. We can use this pulley most times in well, even sometimes in construction sites, or even in lifts that we have in companies. So this is another area of application of pulley. So we mentioned, out of the 6, we mentioned 4 classes of the simple machine. Let's talk about another one, the screw and the wedge. Okay, a screw is just an inclined plane wrapped around a cylinder. You see it here. Okay, and it converts rotational force into a linear movement. A screw, by the time you are applying a force to a screw in a rotational manner, it begins to go downward, until it gets into the object it's made to penetrate. So this is another machine, simple machine that we know. And of course, we use it in bottle caps. For example, most of the wine we take, they are made up of screw. So that if you want to open a wine, you just unscrew it, you keep turning anti-clockwise, and the screw gradually comes out without any stress. Okay, and then also the jacks we use in lifting cars is also made up of screw, so that as you're applying force in a rotational manner, the car will be going up. If you have observed where tire is being changed in a car, you find out that the jack goes up in a vertical manner as the force is applied in a rotational manner. Okay, so because the jack is made up of screw. Then the other one is called the wedge. The wedge is just similar to the screw, but in this case, it's just two inclined planes joined back to back. So an example of this is the knife we use, the axe we use, and the chisel we use. All of these are used as well are the category of wedge, and they help in splitting, cutting, and holding objects in places. All right, so these are the simple machines that we have so far. There are just six of them, six classes of simple machine. Now let's talk about the local application of where we use this simple machine. We mentioned them while we are describing them anyway. So we use simple machine in our homes, just like the pestle and the mortars we use. Simple machine. The bottle openers that we use. Bottle opener is an example of a lever. It's also a simple machine. The kitchen knives we use, also a simple machine because it's under the category of wedge. Then the marketplace, we use the wheelbarrow, which is the second class lever we mentioned earlier. And then we use the wheelbarrow for moving of goods because it is under the category of second class lever. And in the farm, we use hoes, plows, tractors. These are areas where we apply this simple machine. Tractor is an example of wheel and axle because it has wheel and axle in it. Okay, plow is an example of lever. Okay, now artisans also use some of this simple machine, okay, to work. All right. For example, some carpenters they make use of the hand drill, in taking the screw into the object, either the wood or uh, or the a metal surface. Okay. So we use a lot of area of applications in our local areas. Right? Now, let's talk about compound machine or sometimes called the complex machines. The compound machines are just simple combination of two or more simple machines. That's it. For example, the bicycle that we ride is a combination of lever, wheels, and gears. The wheels are the two tires we have. Okay, the lever is just the pedal you're pressing, and then of course the gears are the one that controls both the front tire and being binded together by the chain. Okay, so we also have another one they call the jacks. The jack is a compound machine because it combines both lever and screw together. Okay, the grinding mill is a compound machine because it's a combination of wheel and axle and lever. That's what made them compound machine because they are made by the combination of two or more simple machines. All right, and most industries that make use of machines are also using compound machine to work. All right. Now let's talk about some of these industrial machines. Example, we have the tractors. Okay, we have the rice mills. We have the cassava processing machine. We have the grain threshers. All of these are industrially used. Okay, to produce. Then this machine purpose is to increase productivity. The purpose of machine is to increase productivity and efficiency. All right. Now, machines are also applicable in small businesses. Okay, the water pumps that we use in pumping water, the sewing machine used by tailor, the vulcanizing machine used by vulcanizers in pumping tires, the grinding mill used by market women in grinding some food. Okay, these are small businesses. This business that we apply this machine. Um, At the end of it all, this machine helps to reduce physical effort. Instead of applying physical effort, the machine will do it for you. It will reduce it for you, and it will eventually increase the output. What you will make within 2 hours, within 20 minutes using a machine, you will achieve the same purpose. All right. So this we are going to do the cutting today. Thank you for listening. Bye for now.